Maybe I give you a tip before we go into a numerical exercise. The command pwd, if you type that into Matlab and press return, tells you the current working directory. So like print working directory as an abbreviation, pwd. So we can see what directory you are currently in, and it gives you the full path. If rather than using the Matlab default directory, where Matlab opens up when you just start it by double-clicking on its icon, you wish to have another directory where Matlab should start at the beginning, you can do this by using a function called userPath. So as an example, if I wanted to have my desktop as the directory where Matlab opens when I start it, I type userPath followed by brackets, the round brackets, and in single quotes within these round brackets, I enter this path in completely. So it's user/gb in my case, desktop, and this is what the command would look like for me if I wanted my desktop as a default startup directory. And I don't execute it now because it's set already to this default value, but this is a way that you can simplify your startup and choose the directory which you find most convenient to work in. Okay, so I take this away. And two more things. If you enter clear and press return, it will clear the working memory. So all of the variables that were so far stored in the worker memory are wiped away. Everything is wiped away. And if you type CLC and press return, this will clear the command window. So whatever I have typed so far will disappear if I type CLC. So you can always use that to refresh your command window without losing the content of the working memory. So let's get going. For the following, what we want to do is we want to set up a function. And in order to have a function, we need to define a scale on which this function operates. So let's assume this scale is called time. So let's say we're producing a time series, thinking that later on we'll produce a model of a time series. And you can assign numbers to this new variable time by just typing equal to 0. Time equal to 0. If you return it, see Matlab will respond. It understood that the variable labeled time is assigned a value numerically equal to 0. Thank you. Just reminded that I should enhance the bandwidth by taking my webcam away. So it will allow you to have a larger view of what you see and maybe better follow what I'm typing here. Thank you, Rob. And so far we have time equal to 0 or nothing else. You can do more if you have read the materials. You can also assign an array of numbers or a set of numbers to this variable time, for example, by typing 1:10. If you do this, then the integers, all the numbers between 1 and 10, will be assigned a value in that array called time. And now you can see you produce a set of numbers which goes from 1 to 10. This is a useful thing to do because we can use it for any function in Matlab to operate on that value. So if I go back to time equal to 0, it's now redesigned. Time is just equal to 0, and I want to look at a sine wave. The Matlab function for the sine wave is sin. If I apply sine to the value of 0, then the answer is it's equal to 0. Value of sine of elaborated at 0 is just 0. But because I have something called time which is set equal to 0, I can just evaluate the sine at time. So the argument of the sine in the round brackets is equal to time now, and the value of time is 0. So the sine of 0 is equal to 0, of course, as it should be. Now we make it more complicated. As before, I clear my window and I take this array of numbers from 1 to 10. The convenient thing about Matlab is if I now want to evaluate the sign of time, it will be done for each of these numbers simultaneously. So the result will not be 1 but 10 numbers for each of the inputs, 1, 2, 3, and so on until 10. I get an output. What is the value of sign at this point? So for time equal 1, I get 0.8415. And for the last value, time equal 10, I get minus 0.544. I can also ask Matlab to do it. If I use sign of time, I get those numbers. I can actually assign them to a name. I can store these things in a variable called signFunc. So now they are all into signFunc. And because this is stored in my working memory, I can get the first value of signFunc, which is the value found at time equal 1. And I can get the last value. The last value conveniently abbreviated in Matlab by using END. The last value of any array is called END. So if I get the last value here, it's minus 0.544, which is exactly what we had seen before. Right, that was good, but it was not very elegant. Let's now do a timescale which is a bit more appropriate for the sine waves. For those who remember calculus, the sine wave is a periodic function which is defined on an interval between 0 and 2 pi. So how can you set up an array that goes from 0 to 2 pi? Well, definitely we can do it by saying 0:2 times pi, but as we remember, this will only step up in integers. If we want more than integers, we can give a step size which goes in the middle here. And the step size, I choose a step size of 0.1, and it must be separated from the final value by a colon again. So this thing here will have to be read as define me an array of numbers which starts at 0. It ends at 2 pi, which is 6.28 approximately, and it goes in steps of 0.1. So it will be 0, 0.1, 0.2, and so on. If we want the final value to be exactly 2 pi, we can do it even more elegantly by giving it in fractions of pi. So now we go in steps of 0.1 times pi from 0 to 2 pi. And if we elaborate this array, we get 21 numbers, which are our time scale on which we want the sine wave to operate now. So our sine function, again we call it sinefunc, and we now use our sine function as before, assign of, and we can assign it to time. If we press return, we get 21 values assigned now to this name sine subfunc. And this is what we can use for plotting. I clear my screen and I'll show you the plot. Plot is called plot, a new function which is followed by the round brackets again, and it takes as an argument the horizontal and the vertical axis of what you want to plot. So what's our horizontal axis going to be? Well, it's going to be the time array, and the vertical axis is going to be our sine function. So we have 21 values for time and 21 values for sine function. And if I press return, that will create me a plot, which we can look at immediately. I enlarge the window, and I make the graph the line a little bit thicker. So here we have a thick line. This is our sine function. And if we change the labels, make the labels of our axis somewhat bigger, we can see it indeed goes from 0 to 6 point something, 0 to 2 pi on the horizontal axis, and the values of the sine wave go from -1 to +1 which is what you can check with calculus and is correct. So you have a way of defining functions and plotting them that will be useful similarly for our spirograph exercise later on. Okay, so having done this, I will now hand over to Rob and give you a task. And if you like, you can do the task with us, and Rob will just perform it in front of all of us. So for those who have trouble, can also do it with him. And the task is, do the similar thing what you have done so far with the sine, but generate the cosine. Generate as many values as you have for the sine for the cosine, and plot the cosine as a function of time as we have done here. But as a new thing, plot the sine against the cosine. We'll need that later. Rob, how would you do that?
Hi everyone. Well, Gerald's left us these useful arrays so far. So time, remember, is that. Clear the screen so you can see. And also we've already got our sine func. So if you want to plot the sine func again, we just do plot time. Let's start a new figure first. Figure 1. Okay? And now into that figure, I'm going to plot the time along the x-axis and the sine func along the y-axis. Okay? I move this out of the way. You can see in my figure before, if I make that bigger again, we've replicated the same plot as before. But now we need to do something new. We need to generate the cosine curve. So we do that similarly to before, except now we have a cosine func, and that's going to be cos as a function of the time. And that gives us a new array of numbers. So if you make a new figure, figure 2, and then plot along the x-axis time again, and along the y-axis now our cosine func, now our figure 2 is a plot of cosine. Again, I'll make this bigger. So you can see those are our two functions. They've come into the same window now. So figure 1 is on this tab here, which is the sine plot, and figure 2 is the cosine plot. But now what we want to do is to plot sine against cosine. So if I clear this, we want to start a new figure, figure 3, because we want to keep all the figures we've had before. Okay? Move that to the background again. Now we have another plot command. Instead of having the time along the x-axis, now we want to have the cosine func along the x-axis. And along the y-axis, we have the sine func again. And if I run that and find the window, make the line bigger so you can see it, you can see that we ended up plotting a circle. And that's because as sine varies along the x-axis, cosine varies along the y-axis. And one way to define a circle is by sine and cosine creating a circle in that fashion. Okay, I'm going to pass you back to Gerald now.
Okay, thank you, Rob. So we have seen that we can use the plot function to define different types of plots. And of course, for those who have done the spirograph exercise, they will immediately notice what we are aiming at. If for the sake of practicing you want to do more of this kind, of course you can check what other functions are there in Matlab. And you might use other functions to practice what you have learned so far. If you want to do logarithms, you can try to define logarithms and see what happens. If you want to plot the square root, you can try the square root and see what happens. And of course, sometimes you get error messages, and then you will need to see how you deal with error messages.